All right, we are almost done with the chapter. We just have to do sections 5, 7, and 5, 8, which are really, really similar to each other. It just has a different angle or different approach to them or types of problems. So 5.7, we're just looking at compound interest and specifically interest relating to money problems. So this is going to kind of tackle um, situations like if you put $500 in your bank account and just let it sit there, how much money would you have after 10 years if your interest rate was 9%? Or how much money would you actually owe on your house at the end of like 30 years? Something like that. Um, so we have a couple of formulas here. So there's two ways to calculate compound interest. One of them is to just do it by like a set number of times per year. So like weekly, monthly, every day, once a year. You'd be using this formula. If it's continuously, like you just keep calculating, like it just never, ever stops, that's going to be this formula, which is a lot easier to remember. It's just PERT, like the shampoo. Okay, so let's look at your variables. So the A, that's your amount after T years, or your final. Your R is your interest rate, which you're going to use as a decimal, not as a percentage. The P, that's the principal or the amount that you start with, the amount that you invest, or like a purchase price. T, that's the time in years. And the N, that's the number of times you're going to compound it per year. So if it was like compounded monthly, N would equal 12. If it was daily, N would equal 365. If it was weekly, N would equal 52. Okay. Okay, so we're not using calculators, so we can't actually work all of these out. So you're just going to be pretty much writing expressions. So write, but do not evaluate. So leave it, at like this type of a thing. An expression that will find the amount that results from $700 invested at 6% compounded daily after a period of 2 years. Okay, so we're investing $700. That's the principal. The percentage they give you, that's the rate. But we want to use it as a decimal, so just move the decimal 2 places to the left. So 0.06. Time would be 2 years. And the number of times it's compounded, it said compounded daily. So 365. We're not accounting for a leap year in this class. If you get into, if you're a finance major, they'll show you like what to do with all of that stuff. But for here, daily, it's just 365. And what are we looking for? Well, we want the final amount. So we're looking for your A. So basically, just take all your values here and just plug them into your formula. So A is going to equal 700 times 1 plus R over N, so 0.06 over 365 to the N times T power. So T times 365, or 2 times 365, and that you would want to multiply out. So 2 times 365 is 730. And that's all you can really do with it. You don't really need to simplify the fraction. You can leave it like that. And there you go. Okay, example 2. Again, write but don't evaluate it. So once you get to here, don't do anything. Don't use a calculator. Because if you do, I'm going to know you used one and then you won't get credit. So don't evaluate it. An expression that will find the principal needed to get 60,000 after 10 years at 4% compounded monthly. So your final amount is 60,000 or 60 grand. T would be 10 years. Your interest rate, 4% or 0.04 compounded monthly. So n is equal to 12. So we're going to plug everything into that formula again. So 60,000 is equal to P, because we don't know the principal. We don't know how much we started with. That's what they're asking for. Times 1 plus 0.04 all over 12 to the nt power. So 10 times 12 would be 120. So to solve for P, just divide by that entire mess inside the parentheses. So 60,000 all over 1 plus 0.04 divided by 12 to the 120th power. And we're going to leave it like this. There's nothing really to simplify there. All right, example 3. Write but do not evaluate an expression that gives a number of years it will take for an initial investment of 25,000 to grow to 120,000. Assume an interest rate of 7% compounded continuously. Continuously. That means we're using this formula. Okay, so our final amount is 120,000. Your principal goes over there. It's 25,000. And then it's E to the RT. So your interest rate, 7% or 0.07 to the T. We are looking for what T actually equals. So now you have this exponential equation to solve. So get the E by itself. So divide by 25,000. We can reduce this fraction. So that's just 24 over 5. And we need to get rid of the E. So just like we did before with those other exponential equations, I'm going to throw an ln in there because that will allow me to pull the exponent down. And if I use the ln, so if I take the natural log of both sides, it's not going to allow me to just pull the exponent down. It's going to allow me to cancel out the ln and the e. So I have ln of 24/5 equals, and then on the right side it's just 0.07 t. So I can divide both sides by 0.07. Or if I wanted to, I could use those log properties and split the division into subtraction. Okay, so there you go. So that'll be 5.7. 5.8 is going to be really similar, but it's not limited to finances. Okay, so go ahead and try the homework out and let me know what your questions are.